Hello and welcome to my channel. Today let's look at the Leetcode 496, next greater element 1. So it need to output the next greater element. For example, in the first example, nums1. Nums1 will be a subset of nums2. So nums1's value 412, nums2's value 1342. So for the first value of nums1, 4. In the nums2, it doesn't have a larger element to the right of this value, so it returns -1. Second, nums1's value is 1. So in the nums2, the larger one to the right, the first larger one to the right is 3. So here it output with 3. The third one is 2, which is already the last value in the nums2, so it will also output -1. So the second example, 2 and 4. So this 2, the next larger one is 3, so it will be out with 3. And the 4, it's the last one, so the output is -1. And also the length of the 2 arrays between 1 and 1000. Value between 0 and 10 to the power 4. So all integers in nums1 and nums2 are unique, so it means there is no duplicate values. All the integers of nums1 also appear in nums2. So the follow-up is, could you find a linear solution? So I'm going to, for this question, I'm going to give you the best solution, which is a linear solution. So the linear solution will use a concept called a monotonic stack. So the monotonic stack is you keep the elements in the stack either ascending, in ascending order or in descending order. So I will use the first example as an example to explain how to apply this monotonic stack in this question. So firstly, we can define an array in this because the nums is only between 0 and 10 to the power 4. So we can this array will be similar to hash map, but will be faster. So for this example, we have only 4 elements. So we can this array only need to have between the index 0 to 0, 1, 2, 3, 4. So then we can initialize the stack, and we can start adding the element. We will use the nums2 to add to the stack. So firstly, we add value 1 to the stack. The first value in the stack, it's 1. And then we need to, since we need to keep a strictly decreasing order in the stack. So now the next value we need to add is 3. But because the 3 is 3 is larger than 1, we need to pop. We need to pop this value, the first value, which is 1. But when we pop it, we actually also know the larger, greater value to the right of 1 is 3. So we can fill this value with 3. And then we pop it. We add a 3 to the stack. And then the next value is 4. So because the 4 is also large, 3, large is the top value on the stack. So we actually need to pop out the 3 too. But when we pop out, we can actually also fill the array with the value 4 at the index 3, which means the next greater value at 3 is 4. So then we push the 4 into the stack. Then the next value is 2. So because it's smaller than top value, so we actually doesn't need to pop. So we directly add a 2 value to the. So the values left on the stack, they actually they don't have a value greater than them to the right side. So they actually those values should be -1. So 2 and 4 should be -1. 0 is actually it's not a value with the meaning. So yeah, this then what we need to do is we just iterate through nums1, and then we check if fourth value will be 3, like a -1. So we fill the -1 here. Then once next greater is 3, so we just fill 3 there, and 2 is -1. So we just fill -1 there. Then this is the solution is done. So the time complexity is actually O over n plus m, because we just go through each array once. Actually, because m is also a subset of n. Like m is like a constant times n. So actually it's the time real complexity is O(n). Similarly, the space time complexity is also O(n), which is the value the space used by the stack. So this explains the thought process. So let's we can start implementing the code. So firstly, as I said, we define an array like using all the possible range of the values. So we can define the array called next greater. Then because the max value is we can put 10,001, and then one thing we can do is we can fill this one with -1. So by default it will be -1. There is nothing in the next greater. Then we can define this stack. So in Java, I usually use the deq to simulate to do the stack, deq and array deq. Okay, then let's get out the nums2's length, and then we can start doing the nums2 firstly. So then if the stack is empty, or stack top value is larger than current value, we can just push the nums2 value, then we just go to the next one. So otherwise also in this question there is nothing duplicate, because all the integers are unique, so we don't need to consider the duplicate values. So then if we go down here, then it means the stack top is smaller than nums2I. So then we actually can we can actually start like a pop. So so we pop the value, and then the next greater value will be nums2I. Then until the stack either stack is empty or the stack top value is small is larger than nums2I. Then here now we can in the end we still need to push nums2I. So the second step is we just need to fill out the array. So we can have an answer array called ans, and this one will be equal to next greater nums nums1I. In that we just return answer. Cannot okay nums. Yeah, so the first example shows correct. Let's do another example. Okay. Yeah. So this is example of a monotonic stack. The monotonic stack is also a common like a question in the Leetcode. It appeared many times. This one is more like a basic one. So we might encounter more in the future. So please try to understand and grasp this. So thank you for watching. See you next.